So here they're telling me to guess which substitution I want to make. So before I guess, I'm going to look back at my cheat sheet. So here are the three scenarios that we use for trigonometric substitution. If we have an a squared minus x squared, the sine is the predominant substitutor. If it's a squared plus x squared, the tangent is the predominant thing we substitute. And if it's square root of x squared minus a squared, secant is the key to that one. The problem I was given was an a squared minus x squared. So that means the sine is the key to this one. So before I pick, I'm just going to write out some notes on this one. So let me just steal this. So the square root is what I'm focusing my attention on. And according to my notes, I should let the opposite side be x. 16 is 4 squared, so I should let the adjacent, oops, no, I got that wrong. I should let the hypotenuse be the 4. Because then according to the Pythagorean theorem, this has to be the square root of 4 squared minus x squared. If that's the case, and that's theta right there, the easiest thing to pull out of this triangle is opposite over hypotenuse, which is the sine. So I know the sine of theta is equal to x over 4, so x has to be 4 times the sine of theta. That's the idea behind this method. So then on the homework problem, they say, which is the best substitution here for x? Mine, again, is this one right here, 4 times the sine of theta. Now they want me to do the rest of the setup, and you have two options. You could just look up and use the given versions of the substitution or get them from the triangle. So I'm going to use my get them from the triangle. So I know what x is equal to, so right away I'm going to get my dx. So my dx would be 4 times the cosine of theta d theta. And the square root is adjacent. Adjacent over hypotenuse, this is cosine. So in this case, the square root of 16 minus x squared should be 4 times the cosine of theta. And so now I can start subbing out the pieces here. The 12 on top is a constant multiple, so I'm going to pull that out of the integral. The denominator is my 4 cosine, which is the biggest problem here. My dx is also a 4 cosine. And don't forget the d theta. And the only thing left is the x squared, but if we know x is 4 sine, we can just square both sides. And so x squared should be 4 squared sine squared of theta. And then beautifully here, lots of stuff goes away. 4 divided by 4, cosine divided by cosine. And I'm left with 12 times 4 squared integral of sine squared of theta. What do we do with the sine squared? We use our double angle or half angle formula, right? So reminder, sine squared of theta is equal to, I'm going to write it a little different this time, 1/2 times parentheses 1 minus cosine of 2 theta. Sine gets a minus on that, cosine gets a plus on that. So then I can say this is, I'm going to leave the 12 times 4 squared out front. And then I'm replacing this, the sine squared with this above. So I could pull the 1/2 out as a multiple, leaving just 1 minus cosine of 2 theta. antiderivative. We still have, I'm going to just leave my constants unmultiplied for now. Antiderivative of 1 would be theta, right? I'm integrating with respect to theta here. Antiderivative for cosine is a sine. Derivative of sine is cosine, so we keep the negative. But because of the 2 theta, how do we adjust this?
Divide by 2.
Divide by 2 or multiply by a half, either way. Yeah, I'm going to throw the half in there. One slight catch, like before when translating back, reverse substituting, I know what the sine of theta is. I don't know what the sine of 2 theta is, but there's an identity for that. So I'm going to need another identity. I'm going to put that up here in red, that the sine of 2 theta is twice the sine of theta, cosine of theta. And I know sine of theta is related to x. And I know that the cosine of theta is related to the square root. All right, putting this all together, I've got 12 times 4 squared times 1/2. Okay, so I had sine of 4 times the sine of theta was equal to x. So that means sine of theta is x over 4. So theta would be the arc sine of x over 4. And again, I'm solving, we'll get back there. I'm solving this for theta. The sine of 2 theta there times a half, well, I'm just going to put a little side note here. That's going to be 1/2 times 2 times the sine of theta times the cosine of theta. The 1/2 times 2 cancels. So I'm going to end up with a minus sine of theta, which is really what here? X over 4. Times the cosine of theta. What's cosine of theta here? Cosine of theta, I would just have to divide that 4 to the other side. So it would be the square root over 4. That's a beauty. So this section is about getting used to these trig substitutions, which allow us to solve some square root integrals that we couldn't solve before, and others a couple steps easier than a substitution and, say, integration by parts together might yield a solution to. If I did use a different solution, like a substitution with integration by parts, I probably will get a different looking antiderivative, which accounts for the plus c that we end up with often. Okay. And that happens a lot with trig functions. We get different looking antiderivatives sometimes. They both work. Cool. This is, I think, my favorite Calc 2 topic. I use, what did I just do there? I love